Hi and welcome to this second video in the series on data presentation from the Year 1 Stats course, and we're going to have a little look at box and whisker and cumulative frequency curves in this one. So in the first video we looked at outliers and anomalies, and that's going to pop up again in this video, but we're going to now look at presenting summary data on diagrams and using diagrams to do calculations. So these are both things hopefully that you're familiar with from GCSE, so it's just primarily a recap, and there is one slight difference when it comes to the box and whisker plots. So let's start there, and hopefully we are familiar with that, and straight away you'll notice this has happened. We've got a point here, and this is not something that ever really appears at GCSE, so let's just have a look at what's going on with that. And the first thing we've got is this value here has always been your minimum at GCSE, but we're changing that slightly. So now we're saying that that's our minimum value that's not an outlier. Alternatively, sometimes you might find it being used as the lower boundary for an outlier. So using one of those definitions that we saw in the last video, for example, the lower quartile minus a certain multiple of the interquartile range. When you're drawing these things, it will be very clear to you, or made very clear in the question, exactly which of these two things you need to use when you're drawing them. Everything else is basically the same: lower quartile, median, upper quartile. There's our highest value that's not an outlier, or the upper boundary for outliers. And by now you've probably realised what this thing here is. This point here clearly is an outlier. So that really, that bit to do with outliers and these, the kind of the end of the whiskers, is the only real difference from GCSE. So let's have a look at our data set. Again, taken from the last video, this is our weather data from Camborne in 1987, maximum gust speeds. And if we take all that data, do the calculations we need to do, we did them all in previous videos, and there you go, there is your box and whisker diagram, and there's our outlier that we identified in the previous video. That was 59. And since we've got the data to work with, that means if that's our outlier, this thing here is going to be our highest value that's not an outlier, which is the 56. And that is pretty much the limit of it in terms of just drawing these things. What we have got to do though is be able to interpret them. So let's have a look at one where we're doing a comparison. So we've now got the daily gust speeds for Camborne and Leuchars. And if we're going to do a comparison of these things, we're going to have to comment on which one's got the highest maximum gust speed, and we've also got to make a comment about the variation. So here we go, which has got the highest maximum gust speed. When we're making comparisons, always make sure you make them relevant to the context that you're looking at. So don't just say the median is higher. We're going to say the maximum gust speeds were higher for Camborne, and then we're going to justify it, and we've got two ways of justifying this one. Firstly, clearly the median, which is there for Camborne, which is what's at about 32 compared to around about 20 for Leuchars. So the median's higher. Alternatively, the entirety of this box and whisker is further to the right on our scale, so we can use that as evidence to suggest that the gust speeds were higher in Camborne. And now we've got our second comment, which is about the variation, and we can use either measure of spread that we've got on our diagrams, which is either the range going from the min to the max, or the interquartile range going from Q1 low quartile to quartile Q3. And in both cases on this diagram, we've got more variation in speeds for Camborne, as range and interquartile range are both higher. And then conceivably you might get a question asking you to justify why this was happening. October 1987, the big storm, and it's expected that you know that the storm really only hit the south of Britain, which is where Camborne is. Leuchars, which is up in Scotland, wasn't affected by it in the same way, which is why we're seeing these differences. Okay, and there you go, that's it sorted for box and whiskers. Let's crack on now and have a look at cumulative frequencies. And again, you should be familiar with all of this from GCSE. Essentially, what cumulative frequency does is a graphical way of doing interpolation, which we've dealt with in previous videos. And it's used for medians, quartiles, percentiles, and everything else from grouped data. So here we go. Let's quickly whip through it, but hopefully it's something you're quite happy with. So first job is cumulative, which is add them up as you go along. So there we go. So less than 25 is 6. I know now my table is not quite right, because now we should pretend there's 24 people who are just less than 30. So just imagine now that we're looking at cumulative frequency, we can just ignore these bits here. So we're on less than 25, less than 30, less than 35. It was just too much for us to have to redraw the entire table. So what we're doing now is looking at the cumulative frequency values, these ones here. And we're going to plot them at the upper end of the class intervals, which is 25, 30, 35, 40, 45. there we go. I choose to draw my lines in as straight lines. You can draw them as curves. Either is absolutely fine. Let's not open a can of worms as to why one is preferable to the other. It's not really that important. So what we've got there is our cumulative frequency curve. And now if we want to find the median, we've got 110 values. So our median is the 55th value. So we're going to find our 55th value on the vertical axis. So here we go, up to 55. There we go. Draw across and then read our value off the bottom axis. So we're talking about time taken to swim a length of the swimming pool. The median time was 33 seconds to swim a length of this pool. Okay, so quartiles, same kind of deal as the median. We need 3/4 of the way up, 1/4 of the way up. So there's our upper quartile. Find that on the vertical axis, read off the bottom. Likewise for the lower quartile. And therefore our interquartile range is just the difference between those two things, which is 5. And there we go. That is basically just kind of the same as we had at GCSE. On we go. Last kind of question I get. The number of people who took longer than 38 seconds. So I've included this one just because we're reading the graph slightly the other way around. So now we're finding 38 along the bottom axis, up to the line, across we go. That tells us that 88 people took less than 38 seconds. We would want to took longer, which on a graph is essentially those people up here. And how many people is that? Well, if 88 did it in below 38 seconds, 110 people. That gives us 22 people took longer than 38 seconds. And there we go. So essentially cumulative frequency is just GCSE revisited.